This is question number 4 of May 2017, time zone 2, paper 2. So we're told that a student investigates how light can be used to measure the speed of a toy train. Light from a laser is incident on a double slit, alright? And we're given the graph, shows the variation with time of the output voltage from the light sensor as the train moves parallel to the slits. And so the output voltage is proportional to the intensity of light incident on the sensor. So this is, again, a double slit. Okay. So explain with reference to the light. Okay, I'm going to skip this. The slits are separated by 1.5 millimeters and the laser light has a wavelength. Alright. We're asked to calculate the separation between two adjacent positions of the train. Okay, so this is fairly easy. You just use S is equal to lambda d over d. You have everything here. You have your wavelength, the distance from the slits train track, and so if you substitute in the values, you should get an answer of 2.1 millimeters. Now we're told to estimate the speed of the train. So estimate the speed of the train. So you can check from the graph, and you can see that almost the period is 25 milliseconds. So you can use this, and let's see. So v is equal to delta x over delta t. We have delta t and we have delta x as well, right? Delta x, yeah, 2.1. We just found delta x. 2.1 times 10 to the power of negative 3 over 25 times 10 to the power of negative 3. These will cancel out, and if you calculate that, we get a value of 8.4 times 10 to the power of negative 2 meters per second. So that's the speed of your train. Now part C is really interesting. As this train continues to move, the first diffraction minimum is observed when the light sensor is at a distance of 0.13 meters from the center of the fringe pattern. This is the first diffraction minimum. So determine the width of one of the slits. So now you should consider this as a single slit in this scenario. Single slit. And I'm not sure if I can draw this properly, but try to modulate it, or imagine a single slit modulation till here. And this is basically your first minimum. Alright. So that's your first minimum, and want to find the width of one of the slits. So of course you should use the theta is equal to lambda over b. And I was thinking maybe we can use this S is equal to R times theta, right? Because S over here is somehow similar to, if you remember in the examples of resolution, so you can say S is equal to 0.13, and you have your R as well, which is 5 meters, right? So you can substitute that in here. You should be able to find B. Yeah, so let's see, 0.13 divided by 5 is equal to lambda over B. So B is equal to 5 lambda over 0.13. Now, if you substitute in your values, let me do this quickly. So, let's see, what is the value of lambda? So 6.3 times 10 to the power of negative 7. And then divided by 0.13, right? 0.13. Yeah, and that'll give you value of 2.4 times 10 to the power of negative 5. So 2.4 times 10 to the power of negative 5 meters. Okay, let's see if we have any other calculations. Okay, so that's it for the calculation part.